Hi everyone, in today's video we are going to learn about Git and GitHub. My name is Alexander and in this channel is all about showing you how to become a highly paid IT professional fast. So let's get started. In this video we are going to cover the following topics. What is Git? What is GitHub? How to install Git on your local machine. I will demonstrate some command line usage, and finally I will show you some of the features you can do with GitHub on its web. So what is Git? Git is a form of version control system, and there are two types of version control systems, distributed and centralized. So let's first talk about centralized version control system, which is available on your right hand side. In case you're using a centralized version control system, you're working directly with the server. So let's say you have a source code and you're making a change. Now, whenever you're going to make an update to the source code, any change is going to be committed directly to the server, as you can see in the diagram. So any changes would become immediately available to others, and of course, the most noticeable downside of this approach is that if you don't have access to the server, you're unable to make any updates, or in other words, you are unable to interact with the repository. Now, when you're dealing with distributed version control system, which is shown on your left hand side, and Git is DVCS, it's a slightly different workflow. You have your main repository stored on a server. Then, whenever someone wants to make a change to that repository, first of all, you have to clone that repository from the server to your local machine. Once you have cloned the repository, you would make any changes to your local repository. And then once you're ready, you would push changes from your local repository to the server. And for others, in order to be able to see those changes, they will have to first update their own local repository, and only after that, they would be able to see those changes. So this should cover you the idea of what is Git, what is a version control system, and that there are two different types of them. Now let's talk a little bit about Git itself. Whenever you start working with Git, it can be a little bit confusing if you are doing it for the first time, but once you get the general gist of it, it is actually very straightforward. Your working directory is your actual physical folder which contains your files. Staging area is essentially Git's status. So let's say you have your files, you're making changes to those files. Now, before sending those changes to the actual repository, you would need first to add them to the staging area. This is otherwise known as doing a stage or staging files, etc. Once your files are inside staging area, you can either commit them or push them, or you can unstage them in case you are uncertain. So this staging area is a bit like work in progress area. Let's say you are working on a big project that contains many files. You have modified some files, you have run some tests, but you have realized that your modification have introduced a new bug. So if you didn't have staging area, those changes would have been already sent to the repository, potentially causing breaking change. But in this case, before sending out files to the repository and making a commit, you are staging them first, where you can preview your changes, and after that, if you are satisfied, you can either commit them or you can unstage them. So after we have covered the differences between distributed and centralized version control systems, let's look specifically at Git, how it compares to other existing systems. Most other systems store information as a list of file-based changes. This is commonly described as a delta-based version control. Git is very different. Git thinks of its data more like a series of snapshots of a miniature file system. If files have not been changed, Git doesn't store that file again, just a link to it or a reference. So, in other words, Git thinks about its data more like a series of snapshots. And these two accompanying images will help you visualize this difference. So let's look into GitHub. We have already covered different types of version control systems, and we have looked a little bit into Git. So now let's look at GitHub. What is GitHub? If you remember from the previous diagram, whenever you are dealing with distributed version control system, you still have a server which contains so-called master copy of the repository. And GitHub does exactly that. it allows you to host your repositories, which can be either public or private. Private repositories are restricted, means that only people who have been granted specific access to them can access them, but public are publicly accessible to anyone on the internet. So in other words, anyone on the internet would be able to clone those repositories and then make changes to them. Now you may come across a term known as GitHub Enterprise. GitHub Enterprise at its core offers the same, let's say, package or service as the GitHub, but they offer some additional features which are useful for a large organization, such as more fine-grained access control, specific rules, and etc. But still, all of the products offered by GitHub use the same Git protocol, so they are all interchangeable. How does GitHub compare to other providers such as GitLab, Bitbucket, AWS Code Commit, and of course many more others? So before doing the actual comparison, you need to bear in mind that under the hood all of the services are going to use the same Git. The exact Git version will of course differ, and some vendors will impose their limitations, but all of your basic Git commands are going to work uniformly across all of these different services, because all of them use Git protocol. So what these services actually do differ is that each service offers, say, a unique flavor, maybe a special feature on their website, maybe something else. And of course, there is a question of pricing. So in summary, GitHub does differ from, let's say, GitLab, but fundamentally, if all you're going to do is store a repository and do some basic commands, apart from pricing, there may not be much difference in the end. So now let's go ahead and install the Git. First, I will walk you through the installation process for Windows, then I will cover Mac and Linux. To install Git on Windows, simply navigate to this URL. Let's go ahead and do that. So git-scm.com/download/win. By the way, SCM stands for Source Control Management, and this web page will start downloading the installer. Once you have downloaded the installer, simply double click on it. And now I will walk you through the installer. Click Next. So this one is asking you where would you like to install Git. Let's leave it as default. The next page is asking us if we'd like to use any additional components. In case you're unfamiliar with this, you can leave it as default. It's perfectly fine. And click Next. Click Next. And the next page is asking us which default editor you would like to use for Git. For the duration of this video, I'm going to be using Vim, but in case you'd like to use any other text editor, bear in mind that after you would need to install the text editor separately, and then you would need to configure it using the core.editor option. Now, this recommendation here mentions that Vim is not as good of text editor. However, if you come from a Linux background, you might be quite familiar with Vim and realize that it's perfectly acceptable if you're using an occasional operations with Git. Now, depending on your workflow, you might be comfortable with Vim, or you might use something else if you're not familiar with command line. I'm going to leave this as default, Vim, and hit Next. Next step is asking us which name we would like to use for the new repository. For legacy purposes, it defaults to master, but if you'd like to use a different word such as main, trunk, or development, you can change it. I'm going to keep it as default. The next page is asking us about path environment. In case you're unfamiliar with the path environment or what it does, my recommendation is to leave it as default. The next step is asking us about HTTPS transport. In case you need to use what's called server certificates issued by Windows, such as in case you are part of Active Directory, you would need to use the second option, but other than that, you can stick with the default one. The next page is asking us about line endings, and because of the differences in operating systems such as Windows or Linux, you might need to adjust this setting. Majority of open source software are using Unix style line endings, but in case you're developing on Windows, it will check out as Windows. So this option is what I would call as preferable default, but depending on your workflow, you might need to change it. And the exact, and it's different. It's difficult to say when exactly you would need to change this setting, as it would depend on the configuration on your text editor, your workflow, and etc. The next page is asking us about the terminal emulator, which you like to use with Git Bash. My recommendation is to stick with default min_tty. However, if for whatever reason you prefer to use a Windows default console, you may use that, but this text, this small description shows you the limitations of the cmd.exe. Next, we have a default behavior of git pull. By default, it is fast forward or merge, so let's keep it as that. Then you have a credential helper. As the name implies, it allows you to save your credentials. So if you are dealing with a lot of private repositories that require different accounts, this utility will allow you to save your credential once and then reuse them as needed. Finally, we have some extra options. Depending on your preferences, you can keep them as it is or adjust. And finally, we have a page about experimental features. My recommendation is to avoid using experimental features, as they can introduce new bugs, and if you are unfamiliar with Git, you may not realize that the issues arising are not because you are using something wrong, but because the technology can have some bugs in it. So let's keep it off and hit install. So we have finished installing Git. So let's uncheck this, view release notes, unless you like to preview them, and click finish. And this wraps up the installation for Git. Now to get started, simply open start and type Git. And you're presented with several options here. Remember to use Git Bash. However, if you would prefer to use CMD instead of Bash, you may use that. Bear in mind that both of these are going to use Git. So the difference lies whether you would like to use which terminal emulator you would like to use. If you remember, when for Git Bash we have defined as min_tty, and Git CMD will use CMD as a terminal emulator. So let's go ahead and try it. And let's type git --version and hit enter. And we have confirmed that we have installed Git for Windows. Now you might want to adjust this terminal, the size of the font, colors, etc. So just right click, options, and you have different options here for text where you can change the size of the font and etc. And in a nutshell, we have installed Git for Windows. Now let's go ahead and install Git for Mac. Follow this URL. Let's do that. And you are presented with several options here, and I will walk you through them. Now, the recommended approach is to use Homebrew, and if you navigate to the Homebrew repository, which is brew.sh, you will be presented with a quick guide on how to install Homebrew. And once you have Homebrew installed, you would simply do brew install git. Alternatively, you may use Mac ports, which is an alternative package manager to Homebrew. And of course, you would first need to install the Mac ports, and then you would simply install Git. Now, another way, if you use Xcode, Apple ships a binary package of Git with Xcode, so nothing else needs to be installed. There is a binary installer for Git, but bear in mind it's quite old and maybe not so preferable anymore. Your other option is to build from source, which is something that's more advanced, and you might also install git-gui in case you're using Brew. Finally, macOS itself comes shipped with Git, so unless you would like to use the latest version, your Mac operating system already comes with Git, but you may install something newer in case you like to use a newer version, because by default Mac ships with quite old version of Git. Now the exact version will depend on which version of Mac OS you have installed. Finally, let's go ahead and install Git on Linux. Let's navigate to this URL. And now you are presented with instructions for different operating systems and their package managers. Now, depending on your operating system and package manager, simply copy and paste the given command into your terminal and execute it. Now, the pound sign at the beginning means that you need to execute as a super user, so you would need to replace the pound sign with sudo. And this pretty much should cover the installation process for different operating systems. So now that we have installed our Git and covered some of the theory, let's get on to the practical part. Throughout this video course, I will be referring to the Git manual, which can be found at git-scm.com/docs. And let me open this page for you real quick so you can become more familiar with it. And this is what Git manual looks like. Now, throughout the remainder of this course, I will be making references to this manual so you can become more familiar with it. And if you are more, let's say, seasoned Git user, a lot of your questions can be answered by quickly skimming through the manual on, in terms of different commands and other things. And the first command which we are going to cover is git config. So let's quickly cover git config and see what this command does. Git config, as the name implies, allows you to set, modify, delete Git related settings. This command contains quite a bit of switches and parameters, etc. So I won't be covering all of them, otherwise this video would become too long. Instead, I will cover something more important and something which you need to bear in mind when using this command. This command can be applied in 3 different scopes: global, system, local. Now, when you're using global, the changes are going to be written to this file. When you're using system switch, the changes are going to be written to this file. And finally, when you're using local, the changes are going to be written to this file. By the way, local is the default behavior. So in other words, local is going to be making changes to this current repository. Global is going to be making changes to your global config file available in your home directory, which means that it will affect all of your repositories. And finally, if you have a need to modify system-related Git configuration, you have your system switch here. And to demonstrate to you, let's type git config and then type help. And we have this is pretty much the same information, but on the website it's more readable, as you can see there's quite a bit of information and it can be quite inconvenient to be reading it from terminal. But in a nutshell, one more thing I wanted to cover is that whenever you see a command spelled as git config, most commonly you would replace dash with an actual space. So as you can see, I have written git space config. If you would type git dash config, you would get an error saying that the command is not found. And this pretty much covers everything there is to know about git config. Of course, in terms of actually using it, there is quite a bit of switches, and covering all of them would take a lot of time. And from my personal experience, you wouldn't really need to know everything by heart. So the purpose of this manual actually is that you don't need to memorize all of the switches. You would simply open up the relevant section and would look up. And this pretty much wraps up introduction to git config command. The next command which we are going to cover is git init. Let's go back to the main page of the manual. And this is a command, part of the getting and creating projects. After init, we'll cover clone. So let's have a look at the init command and what it does. As the name says, it creates an empty Git repository or reinitializes an existing one. So let's go ahead and create an empty repository. Type git space. Remember, we replace dash with an actual space, init, and hit enter. And as the command says, we have initialized an empty repository. So let's see what has changed. Type lsl and it looks empty. However, let's include hidden files this time. And as you can see, it has added this hidden.git folder. Let's navigate to it. And let's explore it a little more. As you can see, it has different files and folders added. Remember, I have mentioned previously command git config. Whenever you execute command git config with -- local scope, it is going to write changes here. Config is actually a text-based file. So any git config, you can omit local because local is done by default. Any changes made by git config command are going to be written here. Additional area you might investigate a little bit later is hooks. Now hooks allows you to execute certain, let's say, shell scripts or bash scripts as a part of Git lifecycle. So let's say before committing a message, you would like to execute a certain script to do, let's say, some checking, validations, etc. This folder with hooks contains examples of how to get it done. Now, if you're just starting with Git, my recommendation is to leave hooks until you become more familiar with the process of Git in general, so that you understand, for example, what is commit, what is merge, what is push, rebase, etc. So now let's go back. And a great way to test the current state of Git repository is to type git status. And as you can see, it has confirmed that we are on branch master. We don't have any commits, and it says that we can create copy and files using git add, which we will cover in a moment. Now, all of the information that is being displayed here is actually pulled from this hidden.git repository. So now let's remove this repository and see what happens. And let's type git status. As you can see, it says an error, fatal, not a Git repository. So this should pretty much cover the idea behind Git init. And in case you become more curious what other switches are here, or if you can do something else, you can readily explore the documentation for that. Now let's cover the command git clone. In the previous video we have covered command git init, which allows us to initialize a new repository, but now let's clone an existing repository. Before doing that, first let's explore documentation a little bit. As the name implies, the command does what it says it does, it clones a repository. And there are additional switches which you can use, but for the most part it is sufficient to simply use git clone. But before cloning the repository, we need to create a remote repository. So let's use GitHub for that. Let's open website github.com, and on the home page there are two places which can be used to create a new repository. On your left hand side there is a green button that says new, and on the right hand side there is a plus sign. Click on it and select new repository. By the way, these buttons do the same thing. It's simply a matter of convenience whether you prefer this green button or the plus sign with a drop down. So now let's specify the name for the repository. Let's call it my repo. And let's make it public for the time being, and keep this off, as I will cover this in the next parts of the video. Click create repository and give it a moment. And our repository is ready. Now, if you remember from previous parts of the video, I have mentioned that SSH is the recommended approach to clone a repository, as HTTPS is going to be made obsolete by 13th of August 2021. Whichever method of authentication you use does not impact or affect in any way the contents of repository. It is simply the difference between how you interact with a repository. So use SSH, let's copy our URL and type git clone and URL of our repository and hit enter. And as you can see, it says here cloning into my repo. Warning, it appears to be empty. Now there is another way. If you look at our folder, it has created a folder which is the same as the repository's name, my repo. Sometimes you may be dealing with repositories which have a very long name. So it could be very inconvenient if you have a very big folder name. In order to alleviate that issue, you would simply type git clone URL of the repository space and now type the name of the folder which you would like to use. Let's call it folder 1. And as you can see, it says cloning into folder 1. And let's explore it. And as you can see, it has cloned the same repository, but one was cloned into the default repository, which is going to be the same as the repository's name. And the other one, I have used my own custom name. Now, whichever name you use for a folder, for the root folder, doesn't impact the repository. Both of these repositories are going to be identical. And let's do one more thing. We are going to create a private repository. In order to create a private repository, you would go through the same steps as we have done for our public one. Let's call it my private repo and choose private. You choose who can see and commit to this repository. We keep this as default and we click create repository. Now let's copy the URL and type git clone. It's cloning now the repository, but you have noticed one thing. It did not ask me for my credentials. The reason for that is because I'm using a credentials helper, which means that I have specified my credentials only once, and on subsequent runs, whenever I'm cloning a private repository which requires credential, the Git helper is going to automatically supply it to them. Now, depending on your work environment, this may be against your security policies, but for the current video and for the convenience sake, it is more convenient to use credentials helper. And so we have now covered git clone command. Let's see, and this is it. So now we will go ahead and create our first commit, but before doing that I would like to remind you of the following concepts. When you're working with your local Git repository, there are two parts that you need to bear in mind. Any changes made in your working directory first have to be added to the staging area, which are otherwise known as git index, and the command for that is git add. Once that is done, you can add the changes from the staging area or git index to the repository by means of git commit. So we will get to know the following 4 basic commands to be able to create our commits, which is git add, git status, git diff, and git commit. Let's get started with git status. Using git status is simple. Simply type git status and hit enter. And it will essentially show you if there are any staged or added to the index changes, if there are any unstaged files, and etc. Now, there are some additional parameters here, but they are general. I do not use them on a regular basis unless I need to do something specific or niche. So if you're just getting started, using just git status as is without any parameters is completely fine. Moving on to git diff. Git diff shows you the changes between commits and a working directory, etc. This command has several forms, which are all described here. And for the beginning, we'll cover only two forms, which is this one. And in summary, this form shows you what is in your current directory, which can be staged. So in other words, in a simple form, git diff shows you the difference between working directory and the staging area. Now, the next form which we'll use is -- cached, and sometimes it is used as -- staged. And in this form, as you have guessed, it shows you the difference between staging area and repository. So in other words, it shows you the difference of what can be committed to the repository by means of git commit. And now let's move on to the third command, which is git commit. Git commit essentially records changes to the repository. If you'll have a look at this diagram, git commit allows you to move files from staging area into repository and mark these changes as final. So there are several important switches which you should be familiar with, including --amend, m, which allows you to record the message, and the first one, which is --patch, --interactive, etc. So of course there are other switches available, but these are the most commonly used switches. And the last but not least is git add. As you're already familiar, this command allows you to add file contents to the index, otherwise known as a staging area. Out of interesting parameters, I would recommend --patch, and let's quickly look it up. And --patch allows you to interactively choose chunks between the index and the work tree and add them to the index. So in simple terms, git add would add all of the changes in the file to the staging area or the index, but with patch you can select which parts of the file would be added to the staging area. So, and in terms of how it works, just a final reminder, you're making your changes in the working directory, then you add those changes to the index or staging area by means of git add, and from staging area by means of git commit, you're marking these changes to be saved to the repository's history. So now let's go ahead and try this in practice. So let's bring up our terminal, and the first thing we are going to do is check the status by running git status. As you can see, there are no commits available and there is nothing to be committed. So let's go ahead and create some files. File 1, file 2, file 3, and let's do vim file 1. Let's do insert line 1, line 2, line 3. Now, generally, it is always a good practice to leave an empty blank line at the end of the file, as this allows to run a beta comparison on text files. And let's repeat the following thing for file 2, but instead let's use A, B, C, and vim file 3. Let's use here 1, 2, 3, and empty file. So now let's add all of these files by running git add. Now there are two ways to run git add. You can run with a dot, which means it would commit all of the files available in a working directory, or we can commit them individually like so. Now generally it is always better to commit files individually, as running this format would mean that you might accidentally commit files you did not intend to commit them. So in other words, let me demonstrate to you. We would run git status, and it shows us that we have three uncommitted files that we can add to the staging area. And now let's create another file, let's call it bad file, and let's add something to bad file, bad data, right? Now, if you would run git add like this, right? And we would type git status, you can see that we have staged or added to index all of the files, even the ones that we did not intend to do. So let's go ahead and unstage the file by running this command. And let's check the status. As you can see, we have only file 1, 2, and 3 staged. So allow me to repeat this process again. Let me unstage other files. Let's do git status. And let's run git add file 1, file 2, file 3. Let's run git status. This looks good. And let's make our first commit. Git commit m and my first message. Now we are not going to be pushing it to remote yet, but because we are currently working only with the local repository. So currently I'm focusing on the local repository, and in the next parts of this video I will show you how to push these changes to remote, in other words the server which hosts the repository. So let's run git status. And as you can see, we only have bad file because all of other files have been successfully added to the history, to the repository. Now, to be able to see history, we need to use git log. This command, we did not cover it yet, but if you simply type git space log, hit enter, you would be able to preview all of the information pertaining to the repository's history. So now let's add a few more changes to practice these commands. Let's say that I would like to, first of all, let's remove our bad file since we are not going to need it. And let's make a change to file 1. Let's add an extra line here, line 4, save the change, and git status. Now, as you can see, git status is reporting to us that we have made a change to file 1, which can be added to the staging area. Now but it doesn't specify to us what change we have made. So now let's run git diff and it is showing to us that we have added line 4. Now let's add it to the staging file 1. And now let's run again git diff. Now this time it's not reporting anything, because if you remember, git diff is showing you the difference between working directory and the staging area. Now, if you'd like to be able to see the difference between staging area and the repository, we need to use --stage or --cached parameter. So let's go ahead and do that. Git diff --staged, and it is showing to us that this can be committed. And if you type git status, it will tell us that changes to be committed, modified file 1. And if you would like to unstage the file, we can use git restore stage to unstage it. So let's go ahead and commit this change. Second commit message. And as you can see, we have successfully made our second commit, and we can preview it by typing git log, and it is showing to us both of the all of the repository's history. Now I will demonstrate to you how to stage parts of the file using the git add --patch parameter. So first of all, let's go and make a change to file 2, and let's add a line at the top, and let's add a change at the bottom, hit save. Now let's see what happened. If we run git status, we can see that file 2 has been marked as unstaged, that we can stage it, right? So if we run git diff, it would show us the actual changes. So let's go ahead and run git add --patch file 2. Now, when you're presented with this interface, it can be confusing in terms of how to use it. And lucky for us, it has a built-in help file. So you type question mark, hit enter, and you're presented with a quick explanation of what each parameter does. So the way it works, you would simply type the parameter, let's say Q, hit enter, and it would execute what it does. Now it uses a term called hang, which you may not be familiar with it. Hang is defined as a part of the files that have been apologies. Hang is defined as a part of the file that have been modified. And as you can see, there is a parameter s called split the current hang into smaller hangs. So let's go ahead and do that. And now we can stage just the top of the file, and if you'll scroll up, you remember that Y stands for stage this hang. We will type Y, and we will type N, which stands for do not stage this hang. And presto. Now if you check the status, we can see that the same file is being reported twice, but in different states. The first time it is reported as being staged, and it has some changes in the index which can be committed. And at the same time, the same file is reported that has changes in the working directory that can be staged. So in case this is a little bit confusing for you, I will use git diff to demonstrate to you. Now, if you remember, git diff runs the difference between working directory and the staging area. But git diff -- stage shows you the difference between staging area and the repository. So if we run git diff, it is showing you the changes or differences between working directory and the index file or the staging area. But if you run git diff -- staged, it is showing you what we have staged and what can be committed. In other words, the difference between index file, staging area, and what can be committed. So let's go ahead and commit this. Third commit, and hit enter. So we have committed our staged changes. Remember that this time we staged parts of the file, not the entire file. So let's have a look at our git status. As you can see, it no longer reports that we have something staged because we have committed that. And if you run git diff staged, it would report nothing because our index file, we have successfully committed it to the repository. So now we only have changes in our working directory. So let's go ahead and have a look at that. And as you can see, it is showing to us that we only have this change right here. And the other change, the top part, we have successfully committed to the repository. Now, there is one limitation with git add -- patch, which I will show to you now. Let's say we make a change to file 2. We will add a new line here called bottom 1. Let's go ahead and have a look at git status. It is showing that we have changes in the working directory. And let's go ahead and run git diff. It is showing to us that we have these two lines modified. So let's go ahead and run the same thing again, git add -- patch, file 2, and hit enter. Now let's run question mark, and you will see that the S command is no longer present here. In other words, we cannot split this area into something smaller. And this is actually the limitation of the command. In order for this command to be able to split a change, it needs to have a non-modified part between it. Like initially we had change in the top, in the bottom. So because ABC was unmodified, we were able to split the hang. But since this is one continuous change, we are not able to split it. So this is the limitation of this command. And let's quit the interface by typing Q. But before that, there is a command called manually edit the current hang. And for the sake of demonstration, allow me to show it to you. Now it is presenting you with a more advanced, let's say more low level change, where it says to remove deleted lines, we have to remove the dash symbol. To remove the edit line, we have to delete them. And there is one thing I would mention to you, and this is actually mentioned here. If the patch applies cleanly, the edited hang will be immediately marked for staging. If it does not apply cleanly, you will be given an opportunity to edit again. Personally, my recommendation is to avoid this kind of low-level editing unless you are using, let's say, a visual tool, because when you are marking lines which you would like to add or remove, it's not exactly the same as making a change in a text editor. So it can be very easy to break the process. So in this case, my recommendation is always to simplify your code, right? Maybe if you have one continuous change, create a temporary file, copy the entire change, and then from the temporary file, add those changes to your actual files as needed. So allow me to demonstrate to you what I mean. We have actually committed this file because I have run the manual edit hack and because I did not, let's say, remove the plus sign. So let's bring this back, git staged, right? And file 2. This command essentially allows to unstage the file. And so what I mean by this, let's say git diff, we have bottom 1, bottom 2. Let's let's create a temporary file, tmp, and let's, just for the sake of demonstration, I know this example is trivial, but I'm simply demonstrating to use a concept. We would open file 2, we would copy these changes, and we would save them to temporary file, right? Then we would open file 2, and let's say we would remove this one. And now when we run git diff, it is showing to us that only we have added the line bottom. And once we have committed the line that says bottom, we can add additional changes from our tmp file. I know this example is very silly and very trivial, but imagine a situation where you are making a change, let's say, to a complex file which contains, let's say, a class or a factory, etc. And you have edited maybe, let's say, 70 lines of code. So in that case, this temporary file would allow you to stage and then commit those changes in more, let's say, user-friendly manner, because editing the hack directly can easily lead to a scenario where the patch does not apply cleanly and you have to start doing low-level editing, which can be very difficult and quite frustrating. And this pretty much covers the concept of staging changes using -- patch parameter. The next parameter of git commit, which I will demonstrate to you, is called amend. Git commit amend is typically used when you have made changes to your working directory, you have staged files, you have committed those files, and a few moments later you realize you have forgotten to add a couple of more files to your latest commit. Now this is where git commit amend comes into play. If you look at its explanation in the manual, it can be quite technical, but in a nutshell or in simple terms, it allows you to make amendments to your latest commit. Now, the very important part here is that git commit amend can be used only to modify the latest commit. And if you'd like to make changes to your previous commits, you would have to use git rebase, which we'll cover in a moment. So let's practice this command. Open the terminal with your Git repository, and before doing anything else, let's inspect our existing commits by typing git log. As you can see at the very top, we have our latest commit, which is called third commit, and this is its unique sum. So let's see which files are associated with that commit by typing git log name -only. And as you can see, there is only one file associated with the latest commit. Let's say for demonstration purposes that we have forgotten to add one more file to this commit. So let's first of all create the file by typing touch file form. Let's add some simple changes to this file. Let's save it. And now we would go through the same process as if we were making a regular commit. So we would type git add file form. And now instead of typing git commit -m, you would type git commit -amend. Once done, Git is giving you opportunity to update the commit message as well. So let's use this opportunity and type parentheses amend and hit save. Once done, let's inspect the change by typing git log and name only to be able to see also the name of the files. So as you can see, the sum of the commit have been updated, and this is an important point to bear in mind. Whenever you are amending a commit, the Git is rather creating an entirely new commit. As you can see, the message have been updated and file 4 have been added to the latest commit. There is one more way to use git commit amend. Let's say you just want to update the message and nothing more. In this case, you would simply type git commit -- amend and hit enter. And now let's simply update the message and nothing else. Hit save. And now let's inspect the change. So as you can see, the message have been updated. The files have been left intact because we have been only updating the message. But as you have noticed, the Git have also changed the sum of the commit because it is an entirely new commit. And this pretty much wraps up everything we had to do with git commit. And now we are going to be moving on towards git log. As you can see, git log is a very vast command as it contains a lot of parameters and different options. So to keep it simple, I will focus only on several parameters, which is limiting the number of commits displayed, displaying the names of the modified files, displaying the status of the modified files, showing the actual changes, searching commits by the message name, and finally formatting output in our custom format. So let's open our console and use git log without any special parameters by typing git space log and hitting enter. And as you can see, we have a list of our commits being shown from the very latest at the top and then moving down the chain to the very beginning. So each commit is shown with its checksum message. You have the author's name, we have the date and the message, the commit message. But as you can see, there is quite a lot of information being displayed. So the first thing that we can do is simply limit the output in terms of how many commits are being shown. If you scroll down to the part which shows us how to limit it, we have a section called commit limiting. And we have quite a few parameters here. So I will start with the first one, which is number. Quite simply, it limits the number of commits to output. And let me demonstrate to you how it works. Let's say we want to see just the latest commit, and we would type git log -1. But this is not quite clear enough, so let me clear up the console and repeat the command. And as you can see, we are being displayed just one command. And the same process can be repeated with -n or -- max count. And allow me to demonstrate that. Git log. And as you can see, I have specified 2 here. So git log has shown us now 2 commits. And we can repeat the same process with max count, but in my opinion, the first format is the best one because it is the shortest. So now let's move on to the next parameter. So the next parameter, which would demonstrate to us the names of the files which we have changed. So in order to do that, let's find the command that goes by -- name only, which specifies shows only names of changed files. Alternatively, you can use -- name status, show only names and status of the changed file, which would be something like added, modified, deleted. And this parameter is part of a different section called diff formatting. So let me go ahead and demonstrate to you how to do this in terminal. Let's clear up our console and let's type git log name only. And as you can see, now in addition to our previously seen information, we have a list of file names that have been changed. But this information may not be sufficient simply because it is not obvious what has happened to these files. So let's use the alternative form, which is git log name status. And now, as you can see, we have the letter M, which stands for modified, and it is file 1. We have A, which stands for added, which is file 4. So in other words, to paraphrase this information, it is saying that we have previously added file 1, but in this particular commit we have modified it. File 4 have not been previously added, and it is being committed for the first time. And this pretty much covers information on showing us the names of the modified files. Of course, seeing just the names of the modified files may not be sufficient on its own, so what we would like to do is to preview the actual changes made to the source code. And in order to do that, we are going to use a command called --patch. So let's simply type git log --patch, and the changes are being displayed in a diff format, and it is being displayed for every commit. And of course, we can combine the patch parameter with additional commands such as limiter in terms of how many commits we like to preview. So in this case, it would show us changes just for the latest commit, and that's it. Of course, this kind of format may be a bit cumbersome in case you are not used to the diff format, in which case a diff GUI client would be more preferable. Now let's search by commit message. In order to do that, first of all, let's clear out our console and type git log --grep quote, then type the word which you would like to search for in the commit message, and bear in mind that this is case sensitive. So let's type the word third and hit enter, and we have found commits which match the following word. Now, as I have mentioned, this is case sensitive, so if you use a small letter case, nothing would be found. Now let's explore a little bit this command, since it is a little bit more complicated than the previous ones. So as you can see, this command supports a regular expression, and in case you would like to match the entire grep expression, you would use the --all match command. So allow me to demonstrate to you how to use a regular expression. You would type git log --grep. So in this case, we are saying that we would like to match either capital T or a small letter t. And hit enter. And we have found it. Of course, because this is a regular expression, additional forms are supported, such as, let's say, the commit message begins with the word third, or let's say it ends. Now, bear in mind to escape special characters such as exclamation mark, as they have a special meaning in regular expressions. We would say that we want to find the commit messages which end with the word commit. And we have also found it. This is a little bit more advanced than the previous messages, but this command allows you to quickly find commits by their message. And as I have mentioned, it is a case sensitive, but you can specify the -i or --regex ignore case, and then would match regular expressions ignoring the letter case. And now finally, let's format the git log output according to our needs. In order to do that, we will use a command called --pretty. Before using it, let's quickly dive into manual, and it is available in the section called commit formatting. This command comes with a number of predefined formats such as one line, short, medium, etc. And you can even specify your own format if you would scroll to the section pretty formats. So let's go ahead and do that. So in case you would like to use your own custom format, you would scroll a little bit to the bottom. And here we go. We have format, double colon, and then string, where we would specify the aforementioned placeholders. And allow me to quickly demonstrate to you how it works. We will type git log --pretty =, and let's say one liner. Oops. One line. That's right. And we have used a different output format where each commit is shown on a single line. Additionally, you might want to add in the section pretty formats, it is showing you what it's going to look like. So let's say we would like to use full, it will show us the following output. And finally, let's go ahead and use our custom format. In order to do that, you would type git log -- pretty =, and then you would say format ; and then let's say we are going to use one of the placeholders, which is commit hash, and hit enter. And as you can see, the git log has shown us just hashes of the commits. But let's say we would like to add more information, and we would like to add a space, and let's say add the commit message, which is available under S, which is subject. And we're gonna get an error here saying that ambiguous argument %, %s. So whenever you have a white space in a format, you have to surround it with quotes, and then it will work just fine. And this is pretty much the summary of git log. Of course, as I have mentioned, there is a lot of parameters here, a lot of different options, but I have covered quite a few of them to allow you to get started. And once you're comfortable with these basic ones, you can explore the manual a bit more to try something more advanced. The next topic which I'm going to cover is about gitignore file. There are circumstances when your software, your source code, relies on third-party dependencies. And typically, you do not commit the exact dependencies that you have installed locally. Instead, you would commit the package file, the manifest file, and the log file which contains the exact version of those dependencies to a repository, but you would exclude the actual folder with the dependencies itself. So in order to do that, you would use a special file called gitignore. And as the name says, it specifies intentional untracked files to ignore. So the file itself is actually hidden because it starts with a dot. So inside your repository, you would need to create a file .gitignore, where you would specify your files and folders to be ignored. Now, this file is a plain text. It's not any special format, so any text editor is sufficient to use it. And it follows a certain convention, which is described in the pattern format section. So a blank line matches no files, so it can serve as a separator for readability. In other words, if you have too many entries, it becomes difficult on the eyes to read it, so you can add some blank lines to improve readability of the file. A line starting with a £sign serves as a comment, right? So in case you have a complex file, you would add this additional annotations to improve understanding of, let's say, why a certain folder or file was ignored. Finally, we have an optional prefix specified by exclamation mark, which negates a pattern. In other words, any matching file excluded by a previous pattern will become included again. It is important to bear in mind that it is not possible to re-include a file if a parent directory of that file is included. So in other words, if you have a directory and you have excluded it using gitignore, it is not possible to include certain files from it if the whole directory was previously ignored. Now, there are additional, more, let's say, advanced configurations, such as using 2 consecutive asterisks and etc. My recommendation is to read this whole page, since it is relatively small, and at the end of this page, as you can see, there are examples with some explanations, so you become more familiar with it. So let's get started. So now let's practice using gitignore file using an actual repository. So open up your terminal and make sure we start with a clean slate by typing git status. And first of all, we need to create the actual file, the gitignore file, gitignore. And if you remember, blank lines don't have any meaning inside gitignore file, so we need to add something to it for the file to start to work. So in order to test the gitignore, let's create some files first and test that they are being tracked. And by typing status, we can see that we have untracked files. And let's ignore the first one. Vim gitignore, and let's add a.txt. Type git status, and as you can see, the a.txt file is no longer being shown when we are typing git status. Now, if we'll remove that line and save the change, as you can see, the file is back. Now, let's try the same with the folder, KDA folder, mv asterisk folder. So now we have moved our text file inside the folder. So let's try the same approach using a folder. Let's ignore the entire folder. And to do that, we need to type folder / and save git status. And as you can see, git status no longer shows up a folder because it is being git ignored. Now, one important thing is that gitignore file needs to be actually committed for other users of the repository to be able to see these changes. In other words, when you clone this repository, if the git file is not part of the repository, the folder would show up again. So gitignore should be part of the repository, and that's why it is being shown as an untracked file, because it is meant to be committed. But since we are currently experimenting, we are not going to be committing it for the time being. The next part, let's go to vim gitignore. Let's try using the negation parameter. So let's delete this and save it. As you can see, git status, and the folder is back. So now let's ignore all text-based files. We'll use extension for this and type wildcard, which means any character, any number of characters, .txt, and save git status. And now folder does not show up because, if you remember, you cannot commit a repository as a part of Git. You can only commit actual files, even if they are empty. So now let's include, let's say, b.txt and type b.txt, right? Save and type git status. And well, let's actually stage it to be able to see which files will show up. Git add folder, type git status. And as you can see, file B shows up, but A and C are not part of the folder because Git is ignoring them. So let's unstage this file, b.txt, and let's do the last part, which is the following. If you remember that files already tracked by Git are not affected, and it says C nodes, which is all the way at the very bottom. So let's find this. Nodes. Let's see. The purpose of gitignore files is to ensure that certain files are not tracked by Git remain untracked. To stop tracking a file that is currently tracked, we need to use gitrm. So let's try this behavior. So now let's go ahead and ignore file that is already being tracked by Git. If you remember from the manual, files already tracked by Git are not affected. And it says C nodes. So let's scroll down to the nodes section. Here we go. And it says to stop tracking a file that is currently tracked, use gitrm -- cached. So let's go ahead and try this in practice. So let's inspect our current repository. We have gitignore in folder, and let's inspect the content of gitignore, where we are excluding all text files, but we decided to include b.txt file. So let's commit that file, but first we need to edit folder, git status. Here we go. We have folder / b.txt file, and let's commit it. Git commit gitignore test. And we have committed a file. So now, if we're gonna make, and now let's try to ignore it, right? By deleting the second line from gitignore so that all text files are excluded. And let's add some new changes to this file. Let's press save and type git status. And now, as you can see, even though, right, our gitignore file ignores all text-based files, this file is still being tracked because it was previously committed. So let's go ahead and try the git rm command. Copy and paste it, folder B. There we go. If we inspect status, we have changes to be committed, deleted, folder b.txt. So in other words, in order to start untracking previously tracked file, we need to add it to gitignore and delete it from the repository. However, if we would inspect the actual folder, you will find that the file is still physically here. So git rm is git rm -- cached is not the same as rm. So it's different commands. So let's go ahead and run this command one more time. Ignore previously tracked file. There we go. And delete mode. So now let's make some additional changes to this file. Let's delete this, and this, and save it. And go ahead, type git status. And as you can see, this file no longer shows up. So in summary, this is how you would untrack previously tracked file. So to wrap up the topic of gitignore, I would recommend for you to go through the manual page, all of it, on the git-scm.com. And at the very bottom of it, there is a number of examples with explanations, which will further allow you to assist in understanding how to use gitignore file. And the page itself is not that very big, so it's something that shouldn't take you too long. Now, the last remaining part which I would cover with you is that if you would like to exclude files from a root, you would need to precede them with a /. Allow me to demonstrate that. Let's say that gitignore. Let's say that you would like to ignore a file.txt from the root, but if this file happens to be in any subfolders, you would want to include it. So you would include a / in front of it, and let's try this behavior. Specify file.txt, and let's create a folder. And inside that folder, let's create the same file with the same name. File.txt. Now let's try git status. And as you can see, the root file is being ignored, but the file inside the folder is not. And we can actually reverse that behavior if you want to do the opposite. Include the file from the root, but exclude it from the folder. And let's go to git status. And as you can see, the folder is now being ignored, but the file in the root folder, file.txt, is being tracked. And in summary, this should cover the topic of gitignore. So the next command which we are going to cover after gitignore is git reset. And git reset essentially allows you to reset a state. Now there are three different parameters which, well, there is a number of parameters, but there are three different, let's say, switches which you can use to determine if whether you're resetting your current working directory, whether you're resetting history, or whether you're resetting your index or staging area. Now, the best way to understand how this works is to have a look at this diagram. So you start at the working directory, you make changes to your existing files, and then you stage them by means of git add. From your staging area, you're using git commit command to make an actual commit so that the changes are recorded as a history. Now, in order to move files from history back into staging area, you would use git reset -- soft. To move files from history back into working directory is git reset -- mixed, which is the default value, hence it is written in parentheses. And git reset hard is the most dangerous command because it physically discards the changes made to the files. So I will now go ahead and demonstrate this in practice. So now what I'm going to do is go through the whole cycle of creating a file in your working directory, staging it, and then adding it as a part of a history by means of git commit. Once that is done, I will use commands such as git reset soft, mix, hard to demonstrate to you how they differ. So let's bring up our terminal and create the file. Let's stage the file and let's create a commit with the file. Now, as you can see, our file 5 is the latest commit. However, let's have a look at two commits, our immediate and the one before that. So it is file 5 and ignore previously tracked file. So what we are going to do is now use the command git reset soft, and we're going to specify head caret 1. So in summary, when you're using soft, it means that the commit is going to be discarded and files are going to be moved back into the staging area. And saying head caret 1 means that I'm going to select the commit immediately after the head, which is this one, ignore previously tracked file. And let's hit enter. So let's have a look. Git log 1. Now, as you can see now, in terms of our commit history, this is our latest commit because one before that, file 5, was discarded. And if we're going to look at the git status, we will see that the changes are about to be committed. In other words, this file is in the staging area. So now let's go ahead and try the git reset. So first of all, let's commit the file. Let's have a look that we have our commit file 5 back, and let's run git reset. This time, it's not necessary to specify reset since this is the default behavior. However, sometimes, in case you're dealing with a history, it's sometimes good to be explicit so you don't accidentally run the wrong command. So for myself, I tend to write this to be more verbose to avoid making, let's say, typos or accidental errors. And I would specify again head caret 1, which means that we are going to reset it to this commit. The one immediately before, the one immediately after head, and hit enter. Now let's have a look. Our file 5 commit is gone, and let's have a look at git status. As you can see, we have an untracked file. As you can see, the main difference is that when you are doing a git reset soft, the file is moved back from commit history into the staging area. However, when you are using git reset mix, the file is being moved from history back into the working directory, so we would have to stage the file. So, and let's try the last one, and this is the most dangerous and the most destructive command because it physically removes any changes in your working directory. So let's go ahead and try that. Let's stage the file. Let's commit. And let's run git log 2. So we are back into our previous commit history state, and let's run git reset hard and specify head caret 1, which means that we are going to do a hard reset apologies, into this commit. Let's hit enter. So now let's have a look. Our latest commit now is ignore previously tracked file. However, if you're gonna run git status, it will say that nothing to commit, working tree is clean. So this means that the file was physically removed from the working directory. That's why I have said that this is the most dangerous command, as this is the most destructive. So you have to be really careful when you're doing a hard reset, because if you haven't synced with the remote, if you haven't pushed the changes upstream to the origin or the remote repository, it's going to be very hard to recover your changes from your local machine. And in summary, there is a very straightforward explanation of this command in the documentation git reset --soft --mix --hard. There are additional options which you can make yourself acquainted with to understand how this command works better. But in general, this very straightforward diagram summarizes the concept of git reset in a more, let's say, visual. So now I'm going to talk about Git branches. If you remember, when you initially create your GitHub repository, you are starting out with just a single branch called master. And the main purpose of branches is to be able to isolate additional changes without affecting the main branch. Sometimes it is called trunk. So, and here's a real life world example why this is important. Let's say you have a repository that is being used as a dependency by other developers. And let's say in that repository you're developing a new feature. Now there are two things. A feature cannot fit into a single commit, so the chances are you have to make multiple commits before the feature is ready, and you might also introduce accidental breaking changes. So in other words, you could accidentally introduce bugs. So in order to avoid this scenario, before adding changes to the main branch, you would first create a separate branch, let's say call it feature 1. You would be working on your feature in that isolated branch. You would run your unit tests, etc. to make sure it doesn't break anything. And once you're ready, you will merge your additional branch back into your main branch. So that's one of the ideas behind branches. Alternatively, maybe you're just experimenting with an idea and you're not sure whether it should be part of your product. So it's just an experiment, something maybe you will dispose of if it doesn't work out. So this way, any code, let's say, which is experimental, maybe it is highly untested, etc., would live just in that branch without affecting your main branch, which, let's say, represents your final product. So now let's look at the actual commands in order to create branches. So let's open up our terminal, and the first command is to list available branches, which is git branch. And because we haven't added any other branches, we only have the default one, which is master. So let's create a new branch. To create a new branch, you would have to simply type git branch, and let's call it feature 1, and press enter. And now we have created a new branch. And to check that it was created in fact, let's check the listing again. Now, to be able to switch to, to the newly created branch, you would have to use git checkout feature 1. And we have switched to branch feature 1. And if we check with branch, as we can see, now we have switched to the branch feature 1. Alternatively, there is a shortcut that allows you to create a new branch and immediately switch to it, which is called git checkout -b feature 2. And this command essentially creates a new branch and automatically switches to it. So if we type git branch, we can see that we have created a new branch called feature 2 and have immediately switched to it. Now there is a additional switch which you can use with git branch. It's called -l, which allows you to list available branches, but it allows you to filter, so only branches matching certain regular expression would be displayed. Let's scroll a little bit down in the manual page and find the L switch, right? Let's see, where is it? Here we go. It lists branches, and with an optional pattern, we can only display certain branches. So, as a simple and crude demonstration, let's see, we would have to specify quote, let's call it master, and hit enter. And as you can see, it has shown us only master branch. And maybe we just want to see to list feature branches. So we type branch -l quote feature asterisk and quote, hit enter, and it would show us only feature branches. So finally, to be able to delete branches, you would simply type git branch -d and type feature 1, feature 2. And oh, that's right, we have forgotten to switch. When I type git checkout, I forgot to specify the name of the branch, which I would like to switch to master. Hit enter, and now we have switched to master. And now let's delete branches. So as you can see, when I was running feature 1 the first time, we have already deleted it, and when I tried to run it the second time, it said that there was an error. But I was unable to delete feature 1 because I have checked into it. So in order to be able to delete a branch, you need to check out into another branch. Finally, if you look at the documentation for Git branch and Git checkout, there are some additional parameters available. But my recommendation, if you're just getting started and you're just getting familiar with the concept of branches and how it works in general, my recommendation is to keep it simple, and once you feel comfortable with the basic stuff, move on to something more advanced. So now that I have talked about how to create branch, how to check out branch, etc., I'm going to talk about how to merge branches. And the reason for that is simple. Let's say you have your primary branch and you're developing a new feature. Once you feel that that feature is ready, you would want to merge it back into your primary branch so as to indicate to other developers or other users of this repository that the feature is ready and is safe for use, let's say, in production or public environments. So in order to use git merge, in order to merge git branches, we are going to use git merge, and git merge does allow you to merge more than 2 branches at a time, but my recommendation is to keep it simple and merge only 2 branches at a time, even though technically you can merge multiple branches at a time. And there are 3 distinct strategies for git merge, which is fast forward, no fast forward, and squash. To see the difference between these 3, let's look at the manual where it goes into more depth of explaining the difference. If we would scroll down a little bit, we would come across this part where it says FF, no FF, and FF only, and FF stands for fast forward. So with fast forward, when possible, reserve the merge as a fast forward. In other words, only update the branch pointer to match the merged head, the merged branch. Do not create a merge commit. And when not possible, when the merge history is not a descendant of current history, create a merge commit. And a merge commit is pretty much just like it says, it's a commit that would say merge branch XYZ into the current branch. And bear in mind that when you're using git merge, it will merge into your currently checked out branch. So let's say if you have checked out master and you're merging feature, you would type git merge feature, and you would read this as merge branch git feature into the current branch, which is git master or git main or develop, etc. And let's have also look at the squash, which is a little bit different. So let's see. Produce a working tree and index state as if real merge happened, except for the merge information. But do not actually make a commit, move the head or record. So in other words, when you are doing git merge squash, it will prepare you the working tree and the index state, but it would not make the actual commit. You see, when you're doing git merge either fast forward or no fast forward, it would automatically make the commit. Whereas with squash, your working directory and your index or stage array is prepared, but at that point Git would stop, allowing you to manually make some changes to your either staging or working directory, or even allow you to make your own commit. And it mentions a thing called git head, and for clarification purposes, usually the head file is a symbolic reference to the branch you are currently on. So in other words, head is simply the pointer so that Git would know which branch you have currently checked out. So without further ado, let's go ahead and try these strategies in practice. So let's open up our terminal, where this time I'm using a clean repository. And as you can see, for type git status, we have no commits. So let's go ahead and create our first commit. By the way, we have our main branch. That's right, it's not been listed as because we don't have any commits yet. So let's create our first file. And let's add it. Let's stage it. And we have our first commit and we have our first branch. And as you remember, head is simply a pointer showing to us which is our currently checked out branch. So in order to use fast forward, there is a bit of a confusing term, which means, let me find it, when the merged in history is not a descendant of a current history. So to illustrate this point better, I will show you in a moment what happens with a when we have to use no fast forward. But in simple terms, fast forward is possible when there are no more commits from our current branch. So to paraphrase it, we are starting with our master branch. We're gonna create a new branch, let's call it feature, and add those commits. So granted that after we have created a new branch, there will be no new commits in our master branch, we would be able to use fast forward. So let's go ahead and do that. Git checkout-b, which as a reminder allow us to create a new branch called feature and immediately check it out. And let's create a new file here as well. Let's stage it, git add file b and git commit m file b. Let's check out the log. So as you can see that the head, the feature branch is a direct descendant of the current master branch. So in other words, master branch has no more commits after we have created our feature branch. So let's see which is our current branch. It is feature, and this is actually indicated by head. So if we would like to merge using fast forward feature branch into master, we would need first to check out the master branch and then type git merge and specify feature. So if you remember, git merge is going to merge the specified branch into the one we have currently checked out. So in other words, we are going to be merging feature branch into the master branch. So let's go ahead and hit enter. And as you can see, we have used fast forward in this case. And if you type git log, as you can see, both master branch and feature branch are pointing to the same commit. So now we're gonna try the no fast forward approach. So let's bring up our console again. Let's clear everything up and let's see. We have merged all our previous changes into the master branch. So now we can delete the branch called feature. And now we have only a master branch. So now let's go ahead and create a new branch called feature again. Right, and now let's create a new file here. Let's stage the file and let's commit it. So now I will simulate to you what it means when, let me pull up the reference for you again, when it means that the merging history is not descendant of the current history. All right, so let's see. I'm gonna first of all check out into the master branch and I'm gonna add, let's say, a new file here as well. Let's add the file and let's commit it. All right, so let's inspect our history. As you can see, we have a file D now, right? The commit with the file D is the latest one for the master. But what happened with our feature branch? So let's check it out. Let's check out the branch and inspect git log as well. So as you can see, there is a bit of divergence, right? Because we no longer see the master branch and the feature branch in the same git log when we are switching between branches. And git checkout master. If we would try to force to use fast forward only, this time this would fail. git merge ff only feature, and it says not possible to fast forward. So for this particular case, we would have to use two ways. Either we can use no fast forward, which I will demonstrate now, or we can use a rebase, which I will cover after git merge command. And let's go ahead and remove fast forward only and hit git merge. So now the git is creating what is known as a merge commit. You can actually change the wording here, but you can keep it as it is and simply save it. And there we go. And if we type git log, we have now a so-called merge branch feature, which is known as a merge commit. So now you have more or less an idea what would happen if no fast forward is possible. So if you remember, by default, git merge will try fast forward, and if it's not possible to use fast forward out of the box, let's say like in scenario we had now when we had divergence between branches, it will default to no fast forward, so it will create a merge commit. And of course, if you want to have more granular control over this behavior, you can force the behavior, such as fast forward only, no fast forward, or fast forward, right? But bear in mind that just because you're forcing a certain behavior, it doesn't mean it will work. Like in our case, where we tried to use fast forward and it said not possible. So this is not, so these parameters of the git merge are not actually forcing the behavior. They're simply telling us which options we'd like to use or not use. So if we would say no fast forward, create a merge commit in all cases. With fast forward only, resolve the merge as fast forward when possible. This is the keyword. So this fast forward only would work when it's possible. When not possible, refuse to merge and exit with a non-zero status. And finally, I will demonstrate to you what squash does, but bear in mind that squash is a little bit different from your conventional approach. When produce a working tree and index state if a real merge happened, but do not make an actual commit. So if you remember, in both cases with fast forward or no fast forward, the git would actually make commits. But in case of squash, no commit is being made. So all what it does is preparing your working directory and your staging area. So let's go ahead and try that. Let's clear the console and let's see. We can now delete the branch feature since we have merged it. And let's do some additional changes and try the squash parameter. So first of all, we would have to create some extra files. And actually, I have forgotten, we have to specify, we have first to create a new a new git branch. So let me do that right now. Git checkout b feature. Let's create the file. Let's add the file or stage it. And let's make a commit. All right, let's inspect the log, git log, and here we go. So now let's go into git checkout master. Let's go into the master branch and git merge. Let's say squash and feature. There we go. Let's inspect the log. So as you can see, no commit was made, but if you type git status, the index and the working directory was updated. So squash is essentially allows you to take a more granular control over your commit history when you're using squash, because in this case git would not automatically create commits for you, you would have to create them manually. In conclusion of git merge, my recommendation would be to spend a bit of time getting to know the manual page. As you can see, there is quite a bit of information available, and the topic of merge is quite, let's say, important part of Git workflow, as the idea of creating new branches, deleting branches and merging branches can happen on daily basis, maybe several times in a day. And in terms of which approach would you prefer to choose for Git merge, whether it is fast forward, no fast forward, and squash, is entirely up to you. But there are some technical limitations when it comes to fast forward versus no fast forward. When you create a new branch, it needs to point to the latest commit of your original branch. Because as you have seen in the example, if let's say I create a branch called feature branch from develop branch, and sometime later some other developers would make commits to the develop branch, I would no longer be able to use fast forward option. So in that case, you have two choices. You can either use a no fast forward where a merge commit would be created, or you can use fast forward by means of using a rebase, where you would rewrite the history of your feature branch so that it points to the latest commit in your feature branch. So the last part to talk about when it comes to Git merge is how to resolve conflicts. And conflicts can arise when you have commits which are, let's say you have commits in different branches which have modified the same lines, and computer would not know how to merge it correctly. So it would be up to the developer or the user to resolve this kind of conflict. Another scenario is when you have deleted a file in one branch and you have modified it in another, so the Git would not know whether you should be modifying the file or ultimately deleting it. So let's go ahead and demonstrate this scenario. I'm gonna start with an empty repository, and let's create a file that we are going to modify, and let's add some content here. Now remember, when you're working with Git, it is crucial that every text-based file have an empty blank line at the end. It is really crucial for merging tools, diffing tools, etc. to work correctly. So now let's stage the file and let's commit it. So now let's create a new branch. Remember, -b allows us to create new branch and immediately switch to it. And let's make the same change. Let's modify the same file again. And this time we're going to simply replace letters with, numbers with letters. Let's stage the file and let's commit it. Now let's go back to master branch and let's make some more edits to the file A. Let's add just a new line here and save it, stage it, and commit it. So now let's go ahead and merge. Now remember how merge works. It's going to Git merge is going to merge the branch which you have specified, in this case feature, into your current branch. So to know how to check which is your current branch, you can simply type git branch, which would indicate with an asterisk and coloring. Alternatively, you can use git log limited to just one commit, and the head will point to your currently checked out branch or commit. And remember that head is simply a pointer, nothing else. So in this case, we're going to go ahead and type git merge feature, and we have a conflict. So now I would recommend to you to use a graphical tool to resolve conflict, as it is simply more convenient. The reason for that is when you inspect the file, Git is using these special markers to indicate the conflict, and it can be quite inconvenient if you're dealing with a large code base. So allow me to demonstrate to you how it would work in Visual Studio Code, but the idea would work the same across any text-based editor which allows you to resolve Git conflicts. So let's go to our Git source control tab, and here we have and now Visual Studio correctly recognizes that this is a conflict and allows us different options such as accept current change, accept incoming change. So the current change is the changes which have been made in your currently checked out branch. And the incoming change is change coming from branch which you are merging from. So current branch in our case is master branch, and incoming branch in our case is feature branch. Alternatively, you can choose to accept all or compare changes. Let's go ahead and simply accept all changes. And now let's go back to our terminal since we have resolved it. Right, just one more. And in case of Visual Studio, just a second. All right, now it's loaded. As you can see, it has preserved the commit message. So we can simply say we need to first stage and then hit commit. But I will show you also how to do the same thing using terminal. So we type git add file, and then we are going to commit it. Let me just copy merge branch feature. And that's it. We have merged our branch. So now if you inspect it, you can see how this has worked out. And we have successfully resolved our conflict and merged it into the master branch. And just a personal observation that if your code base is really large, a graphical tool is much more convenient. So it probably makes sense to use a kind of visual tool as opposed to command line, specifically for resolving merge conflicts. And a similar workflow applies when you're rebasing and a conflict occurs. And that's pretty much all to it about resolving merge conflicts. Now let's talk about rebasing and how it works. We have already covered git merge, and I have mentioned to you that fast forward is possible if the branch starts off immediately from the latest commit of the parent branch, such as this scenario. And in this case, such as non-fast forward, if there was a commit 6, it would not be possible to do a fast forward. We would have to do a git merge, which would create a merge commit. Now, git rebase is essentially allows you to change the parent of the branch. So as you can see in this case, this orange branch, it started off commit B, but then sometime later, a new commit C was introduced to our, let's say, master branch. And because of this, it is no longer to do a fast forward. So what we are going to do in this case, we would change the base of the orange branch so that it points to the latest commit in the master branch, which would allow us to use fast forward strategy, fast forward merge, not strategy. Alternative form of git rebase is interactive or simply -i. Sometimes this is known as rewriting history of a branch. When you are doing an interactive rebase, you can decide whether you would like to change the commit message, whether you would like to make change to the actual commit content, such as modifying working directory. Finally, you can squash commits or even delete them. So let's go through a couple of demonstrations to see how regular rebase works and how interactive rebase works, otherwise known as rewriting Git history. So now let's bring our terminal and let's see, we are starting with a clean repository and let's create our first file here. Now let's stage the file and let's commit the file. Now let's create a new branch and automatically switch to it. Now let's create a new file. Let's stage the file and let's commit the file. Now let's go back to the master branch and make one more commit so that the feature branch is no longer pointing to the head, so that the base tip or the base of the feature branch is no longer the latest commit, or other words, head of the master branch. Let's see, let's add one file. Let's stage the file and let's commit the file. So now, if you try to merge our feature branch using a fast forward approach, it would fail. Let's go ahead and try that. Specify FF only. And remember that you want to be explicit if you would like to use fast forward only. Otherwise, by default, if fast forward will fail, Git merge will fall back towards no fast forward approach, where it will create a merge commit. So let's open our terminal and specify feature branch and hit enter. And it is saying fast forward is not possible, and we already know why. So in this case, we want to change the base tip of the feature branch. And the command itself is defined as reapply commits of top of another base tip, or simply put base. So let's go back into our feature branch and run git rebase master. So in other words, we are saying that we want our current branch, which is feature branch, to use the base tip or head of the master branch, and hit enter. Oh, I made a typo. And hit enter. And we have successfully rebased and updated. Let's go back to our master branch, and before doing anything, let's have a look at our log. So as you can see, my apologies, we have to check out the feature and do a git log from here. So as you can see, now the feature branch is starting off from the latest commit in the master branch. So as you can see, this is the latest commit of the master branch, and immediately after it, we have a commit for the feature branch. So now git merge ff only, fast forward only. Let's go back into our master branch and do git merge fast forward only and specify feature. And it has worked. Fast forward have worked, and this is in a nutshell how regular non-interactive rebase works. Of course, there are additional more advanced commands, such as using dash onto, dash keybase, etc. And my recommendation would be twofold. First of all, it makes sense to go through this manual page, even though it's quite lengthy. It has a lot of visual examples to understand how this command works. Finally, if you're just getting started, my recommendation is not to try to overwhelm yourself with more advanced usage and just stick to simple commands at the very beginning. Now let's go ahead and try interactive rebase, otherwise known as rewriting Git history. So let's open our terminal, and we are starting with a clean repository as well. So let's add some files. Touch file A, file B, all right, B, C, D, E, and we have created a bunch of just empty files. So let's stage them and commit them one by one. So let's go ahead, file A, and let's go ahead, git add and git commit m file A. Now let's go ahead and repeat this process for the remainder of the files. D, and finally E. So now if we will look at our Git history, we have quite a few commits now. So before starting the actual interactive rebase, you need to bear in mind that when you specify the rebase point, it will start from the next commit. So for example, if I will specify this commit as a starting point, it will actually allow me to modify any commit after this commit. So allow me to demonstrate this. Git rebase I, and let me specify this commit. And as you can see, commit, the very first commit is not here. So if you would like to actually include your initial commit, have to specify a special parameter called root. And it has quite extensive documentation in the manual page. So, but simply put, let's go ahead and try it again, git rebase I, and this time let's specify root. So as you can see, we can make changes to all of our commits, including the initial one. So how this works is very simple. First of all, you have a command, right? The first column, and below is an explanation, and it has a shortcut. So for example, instead of typing peak, you can simply type letter P. Instead of, let's say, break, you would type letter B, etc. And you have some actions which you can do with these commits. By default, when you use peak, it simply says you use this commit as is without making any changes. Reward allows you to change the commit message. Edit allows you to modify the content of the commit. Finally, D stands for dropping the commit altogether. In other words, any changes that were included in the commit will be discarded. The entire commit will actually be discarded. So don't confuse this with removing the content. This is not the same as deleting files. This is actually deleting the commit itself, not deleting the files inside of this commit. And we have some additional commands, but let's say some of these commands can be a little bit more advanced, and for most of the part you can stick to simply peak, reward, edit, and final one, squash. Squash allows you to simply merge commit with the previous one. So if I would say, let's say, I would say here S or squash, it would simply merge this commit with this commit. So any changes made in these two commits will be presented as a single commit. Now bear in mind that it can lead to merge conflicts, so you have to be careful with this one. So to demonstrate how this works, I'm gonna drop this commit. I'm gonna use abbreviations. I'm gonna drop commit file D. I'm going to reward commit for file C. I will squash this commit with the previous one, and I'm gonna edit the very last commit. So once you have done these changes, you would save the file. And now we are at the stage in the process of rebasing. So this is interactive rebase, and this is the first part where we are squashing our second commit with our initial commit. So as you can see, lines which are starting with a pound sign will be ignored, and an empty message aborts the commit. So let's say that I want to produce a single message, file A and file B. So now I would simply save the change. And now we are in our next part of the rebase. As you can see, interactive rebase in progress. Last command done, squash, reward. Next command to do, remaining two, drop and edit. And as you can see, we are now in the part reward of this commit, which simply allows us to reward it. Now, this might look similar, but it's not the same thing. When you're squashing commits, Git will always ask you to update your commit message. But when you're doing a reward, it is not making any changes to the content of the commit. It is not modifying history, it is simply changing what is written here. So let's say I would want to say new file C and save it. Now we are in the part of making the changes. Git, and if you would type git status, it says interactive rebase in progress. The last command done, drop, edit. So now we are actually editing. Now we are doing changes. We are actually rewriting the history of the rebase. So let's go ahead and modify file E. And let's make some changes. New line and hit save. Now, remember, we have to use git commit amend, but before doing that, don't forget to stage your changes. It is crucial because the process is the same, whether you're creating a new commit or editing a new commit or editing an existing commit using interactive rebase, you always go through the same cycle. Make change in your working directory, stage that change, and finally commit it. Well, in this case, we need to use amend. So this is another important part to bear in mind. So I'm going to stage the change, and then I'm going to use git commit amend. So as you can see, we are given another opportunity to edit our commit message. We would save it. And let's go ahead, git status. We would type git rebase continue. Now, sometimes when you're just getting to know git rebase, you can forget about it, but it's a really crucial point. As you can see, we are currently in the middle of interactive rebase. So in order to finish it, we have to tell Git that we have finished amending our current commit and would like to continue. And hit continue. So now, if you type git status, it will say that on master branch, nothing to commit, working directory is clean. So let's go ahead and inspect our changes. So first of all, as you can see, the commit we have fewer commits because one commit was deleted and one was merged. So instead of 5, we have 3 now. So as you can see, commit file A and file B has been squashed together. Commit with the file C was rewarded and commit with the file E was modified. And let's inspect file E. So as you can see, it has new content now. So in a nutshell, this is how you would do interactive rebase. And pretty much this covers most of the basic idea of the Git rebase, whether it is regular or interactive. And now I will talk a little bit more about the theory since it is really crucial. When you're either simply changing the base of the branch or rewriting the history by means of interactive switch, you need to bear in mind that it will make changes to the whole chain of your commits. In particular, it is going to change the checksum. In order to provide data integrity, Git calculates checksum for every commit. So whenever you modify anything, including file, date, commit, message, or anything that is contained in a Git commit, the checksum or the ID is going to change. So if you're just one person working on one repository, this is not a problem. But if you work in a team of people and you would rewrite the branch's history, it's going to change those IDs. So for other users, it will present to them a problem when they're pulling the latest updates from the remote server. They're going to run into merge conflicts and head detached state and all other kinds of issues. So this is the primary reason why primary branches such as main branch or master branch simply do not allow you to rewrite its history. It's because of this kind of issues. But for, let's call them auxiliary branches such as bug fixes, features, etc., it would be completely appropriate to rewrite history as long as either you are the only person using that branch or you're able to communicate with us, the developers, that you have rewritten history so that they are going to be aware of this change, so they're not caught by surprise when they have written their part of the work and now trying to push it to the remote server and it is being rejected. So far, we have been dealing with a Git repository which is purely local and only available on your system. But typically, as a part of your Git workflow, you have a remote repository. So any changes you have made in your local repository would then be pushed, or let's say sync, to the remote repository. And this is what your typical workflow would look like. You would start with a remote repository, which is available at the remote server or a third-party vendor such as GitHub. Using git clone, you would clone this remote repository into your local system. Then you would go through your typical workflow of editing files, staging the files, and then committing them to your local repository. From here, you would push those new commits to the remote repository, and other developers would then pull the newly added remote changes into their local repository by means of git fetch and git pull. And these commands, of course, are documented in the Git's manual under the section sharing and updating projects. So you have git fetch, git pull, git push. And you also have, let's say, a more admin tool called git remote, which allows you to do some maintenance things. So now let's consider each command in more detail. So let's start with git remote. Git remote allows you to manage a set of tracked repositories, which is by definition going to be remote. And this command is not going to be used on a regular basis, but only once in a while. For instance, let's say you have created your Git repository locally by means of git init, and then you need to specify information about the remote repository so that you would be able to push those changes from your local repository into the remote. Another example when these commands come handy is when you have renamed your remote repository, so the URL of the remote repository have changed. And in this case, you would also use git remote. So let's consider these two examples in more detail by actually practicing it. So let's bring our terminal and initialize our repository by typing git init. So as you can see, we have initialized an empty Git repository. Let's add an empty new file to create our first Git commit. And we need to stage it first, and then let's commit it. And if you would look at the Git's history, as you can see, we have created our first commit. But this information is purely local. So now what we are going to do is head over to GitHub, create a remote repository in GitHub, and then using git remote, we are going to add information to our local Git repository. And then we are going to push our local changes to the remote repository. So now let's go ahead and head over to GitHub by typing github.com and clicking the green button new. Let's create our new repository. Let's give it a name and simply click create. So now we have our remote repository, and we also have the URL for our remote repository. So in order to add our remote repository to our local one, we are going to issue command git remote add. And let's do that. Git remote add and type URL. But such usage is not correct one, as the syntax is git remote add options name URL. And the name can be anything, but by default and for reasons of convention, it is typically you are going to use the word origin. So let's repeat the process: git remote add origin and then URL. And we have added the URL for the remote repository. But that on its own is not sufficient, because if you would type git push to push your local commits, your local changes into the remote repository, you are going to be presented with an error message. The current branch master has no upstream branch. And Git, a newer version of Git, provides you with this helpful message, which you can simply copy and paste. And hit enter. And depending on how many commits and how complex is the change of the history, how big it is, it can be instantaneous or it can take a few seconds. But in general, the process of pushing commits is very, very fast. So if you'd like to inspect the changes made to your local repository, you would need to inspect this file available at .git, which is a hidden Git folder, and the name of the file is config. So the first command, which is git remote add, has added this information. And the second command, which is git push -- set upstream origin master, have added this information. So the way Git works is that every local branch needs to be mapped to a remote branch. And for reasons of ease of use and convenience, my recommendation is to keep the mapping one-to-one. So let's say if you have a local branch master, it would be much easier if the remote branch was also named master. But of course, if you like to go for a more advanced configuration, it is not necessary to keep the mapping one-to-one. But if you're just getting started with Git, my recommendation is to keep it as simple as possible. And if you would head over to our remote branch, if you would refresh the page, you would see that the commit have now been successfully pushed from our local repository into the remote one. As you can see, we have our commit message. And if we look into more details, we can see that our file, our new empty file, have been successfully added. So now let's consider the second scenario where we have created our remote repository, but then have decided to rename it. So we'd have to use git remote command to update the remote URL. So now let's go back to our remote repository, which is hosted on GitHub. Go into the settings. And at the very top, you will be presented with an option to rename the repository. So simply type the new name and hit the button rename. After that, we are going to use the command git remote set URL. And in this case, you need to bear in mind that you need to use the same word we have used initially. So in our case, the name was origin. But in case you have decided to use something else than origin, you need to make sure that you are using the same name. Otherwise, this command would not work successfully, as Git would assume that you're trying to add a new remote URL instead of updating the existing one. So let's bring our terminal and type git remote set URL origin and provide. And I have forgotten, we need to copy the new URL, and it is available. When you hit the green button, you will be presented with commands with the URL in order to be able to clone it. So let's copy, let's paste it here and enter. And we have done it. So if we would inspect our git config, you will find that now it is using the new URL instead of the old one. And in case you don't remember what you have named your remote, you can simply type git remote, which will show you the names of the remote, as git remote allows you to set multiple remotes. But by default, git remote is not very meaningful, as it simply shows you the name. So you would need to execute it with a verbose parameter to be able to see what the name of the remote maps to. So in other words, to see how the name of the remote maps to which URL, as you can see here. So now let's consider the command git push in more detail, since we have already used it. And let's open up the manual page. And for the most part, you will find using yourself git push without any parameters. And simply what the git push does is it pushes your new local commits from your local repository to your remote one. However, there are a couple of parameters which you should probably be aware of. The first one is --force, and the other one is --prune. So let's have a look at those. So let's scroll down to the first one, which is --force, and let's scroll down. Let's see. Here we go. Let's see what the manual page says. Usually the command refuses to update a remote ref that is not an ancestor of the local ref used to overwrite it. So in other words, this kind of situation occurs when you have used rebase, or simply put, you have rewritten history. Another situation when you have to use this command is when you are using amend, when you're using git commit with amend parameter. So let's try these two scenarios in practice. So let's bring up our terminal and let's create a new commit. So first of all, we need to create an empty file. Let's stage it, and then let's commit this file. There we go. Now, if we type git log, we will see that we have a new commit available in our local repository, but our remote repository is have not been synchronized. It has not received our latest commit. So in order to do that, we would simply type git push to push our local changes to the remote repository, and then let's repeat the process, git log. And now you can see that local repository and remote one are both pointing to the same commit for the master branch. At this point, let's pretend that we have realized that we have forgotten something else in our commit, and let's use git commit amend parameter for that. So let's make some changes to our file, and let's execute git commit amend. Let's keep the commit message as it is. And now let's see, before pushing the changes, let's have a look at git log. Now you will notice that origin master is no longer showing up in our git log. Even though the commit message is the same, you will notice that the checksum is different. And if you remember from my previous part, whenever you're making any kind of change to git commit message, its checksum will update, even if you haven't modified the files and let's have changed only something as trivial as date. Its checksum will also be updated. So if you try to do git push, we will see that the remote server have rejected our changes, our updates. And in order to and one of the ways to overcome this issue is by using git push force. So in this case, our local repository will forcefully override our remote repository. But bear in mind that using such approach will cause issues like we have experienced here for other developers, where if they have, let's say, pulled our branch and then we have subsequently rewritten it, if those developers will try to push any updates from the local repository to the remote one, they will be faced with a similar kind of error message. So now let's go ahead and try the second scenario where we are using git rebase. And for the rebase part, let's do an interactive rebase. But before doing that, let's create one more commit. Let's have a look. Let's create one more empty file. We call it C. Let's add it. Let's stage it. And finally, let's commit it. And last but not least, let's push it to our remote repository. So now, let's run a git rebase on our master branch interactive, and let's start at the root. So in this case, let's say that we have decided to rename commit message for our second commit, which is B. And let's use a reward parameter for this. If you remember reward, use commit, but edit the commit message. Let's hit save. And let's say, let's put here 1, just to make a new change. And finally, let's try to push our changes by means of git push. And as you can see, we are getting a similar message saying that the remote repository, the remote server, has rejected our push. So now it becomes more obvious why the idea of rewriting history, while may sound appealing at first, you will realize that it can break the operations for other developers. Because if you would rewrite history and then use force push on your branch, but other developers are using the same branch, when they will try to push their commits with their work, they will get a similar rejection, and it can be quite cumbersome or sometimes downright difficult to merge changes once you have this history divergence. So for this reason, typically your primary branch, such as your master branch, is going to be protected, which would not even allow you to use force push at all. And now let's have a look at the -- prune parameter. So let's scroll to the top as a reminder that we have this -- prune parameter. And let's have a look at its definition. Remove remote branches that don't have a local counterpart. So what this means is that When you are making changes in your local repository, there is no automatic mechanism to keep your local and remote repository in sync. You need to do that manually if you're using a command line Git, or some of these operations can be automated if you're using a GUI based Git client. So allow me to demonstrate this. So let's bring up our terminal again, and to check how this behavior works, first we need to create a branch and then push it to remote. So let's do git checkout with -b to create a new branch and automatically switch to it. Let's call the branch feature. And now we need to do git push. But because we are creating a new branch, there is no upstream branch which we need to specify by means of this command. By the way, this command will automatically reflect the name. So if let's say I have decided to use the word branch 1, instead of displaying feature, it would display branch 1. And now let's go to Git's website, GitHub's website, and refresh it to make sure that our branch is actually here. And as you can see, we have 2 branches now instead of 1. And as you can see, we have the default branch master, and we have our new branch feature, which we have pushed just now. So let's go back to the terminal, and let's do the following. Let's delete our branch by means of git branch -d and the name of the branch. But we cannot delete the branch if we have checked it out, so we need to switch back to our master branch. And now let's delete the branch again. As you can see, we have deleted our branch, and if we type git branch, we will see that locally we only have master branch. However, you can display remote branches by means of git branch -r, and you will see that in the remote we still have our branch feature, and if we would refresh our GitHub page, you will see that our branch is still here. So in order to remove the branch, we need to run the following parameter, and we can actually copy directly from the manual page. Copy and simply paste it. But I have forgot, but you need to make sure to update the word. As you can see, here you need to specify the name of the remote, in which case we use origin, and hit enter. And it says that it has Git has deleted the branch feature in the remote. So let's refresh our GitHub page. And as you can see, the branch feature is successfully gone from our remote as well as local. So if you would type git branch -r, you will see that origin feature is no longer being shown. But as you can imagine, this is not very convenient. So what I personally prefer to do is to remove the branch from GitHub by using the web interface, and then when I use git pull with a similar parameter to prune branches in that way. And now let's have a look at git fetch command. As you would imagine, git fetch simply downloads objects and refs from another repository, in this particular case the remote repository, and when git fetch is used without specifying a remote, it will default to the origin, which is why I have recommended to use the word origin for the name of your remote. So let's go ahead and try this command in practice. So I will again bring up my terminal, but this time I will make a special note that I have cloned the same remote repository into 2 different folders to demonstrate how git fetch works. So let's create a new commit by means of creating a new empty file. Let's stage it, and let's subsequently create a commit from it. Now let's push my changes to the remote repository, my new commit. And now you will see that my local branch as well as the remote branch master are pointing to the same commit. However, if I will look in my other local repository, I will type git log, you will see that my other repository is still thinking that commit with the letter B is still the latest one. So let's execute git fetch. As you will note now, by means of git log, that not much has changed. However, if you type git log origin master, you will note that there is a new commit available. So in order to, let's say, switch or for that commit to be available in my local master branch, I would have to do git merge origin master. And now if I will type git log, my local branch as well as the remote branch master are pointing to the same commit, and as you can see, the checksums are the same. However, doing this manually can be not so convenient, which is why for the most part developers would use git pull, which we'll now consider next. So let's go back to the manual page and bring up the information on git pull. And git pull is described as fetch from and integrate with another repository or a local branch. And if you will have a look at the description, it is very straightforward. Incorporate changes from a remote repository into the current branch. In its default mode, git pull is a shorthand for git fetch followed by git merge fetch head. Fetch head is a temporary reference to what we have recently fetched by means of git fetch. More precisely, git pull runs git fetch with the given parameters and calls git merge to merge the retrieved branch heads into the current branch. With -- rebase parameter, it runs git rebase instead of git merge, which, as you have seen, is similar to what we have done when I was describing git fetch. So now let's have a look at its additional parameters. Unlike other git commands, since git pull is a combination of git fetch and git merge, if you will look at the actual parameters, you will find that it is a combination of options relating to git merge and git fetch. So you are already familiar with these parameters since I have covered them in the previous parts of the video. Finally, when you run command git pull for the first time, you will get this kind of a notification or a warning saying that pulling without specifying how to reconcile divergent branches is discouraged. And even though by default the regular git merge is a chosen strategy, unless you will explicitly set it to this value, you will continue to get these warnings. And it is possible to use git rebase as an alternative to git merge, and it is possible to force fast forward only strategy, but bear in mind the consequences of using these commands. And in summary, this is the foundation of basic usage of git pull. So now, since I have covered how to deal with a Git remote repository, I will discuss some of the features which are exclusive to GitHub. So to get started, let's navigate to GitHub, open your repository and click the Settings tab. At the very first page, you will find the ability to rename your repository by typing new name here and pressing the rename button. You have a social preview where you can upload a custom image, which would be shown when you are sharing your repository's URL on social media websites. Followed by this, you have features, and these features are pretty much straightforward, so all you need to do is simply read the additional text here to understand what it does. To enable, you would simply tick it, and to disable, you would simply untick it. Then you have the merge button. Merge button relates to pull requests, which I will discuss in a moment, but for the moment I will explain the merge strategy, since it's not exactly the same as your regular Git application. When you are using the default merge, a merge commit would be created, nothing new. When you are using squash, unlike your git merge -- squash, in this scenario, all of the available commits in the branch will be squashed into one to produce one big commit. After that, you have your rebase merging, which is similar to regular merging strategy, except that a merge commit would not be created. Allow auto merge was added recently and it's experimental feature, so it can have some bugs since it was added quite recently. Finally, we have this button called automatically delete head branches. When you're doing a merge, let's say from feature into master, if this is going to be ticked on, if you have successfully merged feature into into master, feature branch would automatically be deleted, but you would still be able to restore branch from the PRs page, from the pull requests page. Finally, we have archives, which deals with Git LFS, and Git LFS is a little bit more advanced concept, but in a nutshell, it allows you to remove very heavy in terms of size objects from your Git repository and stores them in Git LFS. Then you have GitHub pages, which is essentially a publicly viewable markdown pages rendered by GitHub. And finally, you have danger zone, where you can change the visibility of the repository, transfer an ownership, archive the repository to mark it as a read-only, and finally, delete repository. Bear in mind that when you're deleting a repository, if you're using a free or even paid GitHub subscription, there would not be any kind of backup provided to you by GitHub itself. So it would be your responsibility to make sure that you have a backup in case you accidentally delete an important repository. So my recommendation is that prior to deleting the repository, Git clone it locally, make sure everything have been cloned, including branches, tags, etc., and then you can delete this repository. So going forward, you have manage access tab, where you can specify, and when you are accessing this particular page, manage access, you would be access to provide your password again for security reasons. And in here, you can specify or send invitation to collaborators. Then you have security and analysis tab. And this part of the settings relate to third-party dependencies, where you can create a dependency graph, you can opt to receive dependency alerts in case your third-party dependency have vulnerabilities. But bear in mind that not all languages are supported, so for your particular use case, it's always best to consult GitHub's manual to see if you are able to use any of these features for your particular language, as these features are language dependent. Now let's consider a section called branches. Here you can specify the default branch, and the settings affect the following. The default branch is considered as the base branch in your repository against which all pull requests and code commits are automatically made. So in other words, this setting affects GitHub specifically, but let's say if you would change master here to something else, and using command line git, you would clone your repository, you wouldn't be able to see this setting or how it affects the repository, because this is Git specific setting. Then you have branch protection rules. Define branch protection rules to disable force pushing, prevent branches from being deleted, and optionally request status checks before merging. And to be able to create a rule, you would simply click the add rule button. Additionally, if you are new to protection rules, GitHub has a dedicated section in its manual which explains all of the available settings in more detail. And at the very top, you can define the branch pattern to specify which name pattern you would like to protect. And here you have additional checklists, protect matching branches, and all of these checklists have accompanying explanation text available underneath each checkbox and inside the manual page for this specific GitHub feature. You have a more detailed explanation of what happens here and how it works, etc. Finally, you have rules which are applied to everyone, including administrators, which would allow you to undo restrictions, which is allow force push and allow deletion. Because by default, a protected branch does not allow you to permit force push, and it does not allow to be deleted. In other words, if you try to run this command against your remote, you will get an error message saying rejected or something like that. So now let's go to the next section, webhooks. Webhooks allow external services to be notified when certain events happen. So in other words, webhooks is a way you can integrate your specific GitHub repository with a third-party service, such as, let's say, instant messenger Slack. So let's say someone creates a pull request on GitHub and then by means of webhooks, an immediate notification in Slack channel would be posted saying this particular person has posted this particular pull request. Going into notifications, you'll find that this is simply a way to set up 2 additional email addresses when push requests are triggered. And to specify, at most you can specify only 2 email addresses. Next, we have integrations. GitHub apps allow you to augment and extend your workflow in GitHub. And to be able to install a GitHub app, you would simply Google for the word GitHub apps. Open GitHub Marketplace, where you can find the additional GitHub apps. Simply click on any of the links and then follow the instructions on installing it. Now, bear in mind that there are commercial as well as free GitHub apps, so it would really depend on what you're trying to do with your repository so as to avoid unexpected billing. Finally, once you have installed and activated the GitHub app, it would be listed here. Then we have deploy keys. This is used by a part of continuous delivery pipeline, and more information can be found by following this link. Next, we have actions, environments, and secrets. Actions or GitHub Actions is a way to set up workflows within GitHub and are typically used as a part of CI and CD pipeline. Environments and secrets allow you to set up a more advanced configuration of GitHub's actions. However, at the moment they are in beta stage and are subject to change. Finally, the last section of settings is called moderation settings, which allow you to create temporary interaction limits. This is useful in case you have, let's say, a heated discussion, or you would like to prevent unwanted interactions as a result of, let's say, user abuse. Bear in mind that this is temporary limitation, because if you would try to enable one of these limitations, you would have to specify the time interval. And for each limit, there is a detailed explanation with hints allowing you to understand how one of these limitations would impact your repository. Finally, I will demonstrate how to create a pull request or PR. So in order to create a PR, you would have to create a local branch, push it to remote, and then navigate to GitHub's website. Open the specific repository, and then you will be presented with an option to create a pull request. So let's go ahead and try that. So I'm going to bring up my terminal again, and I'm back in my local repository. So let's create a new branch by means of git checkout and specify -v so that we would immediately switch to it as well. So let's call this branch feature. And now we have switched to our new branch feature. Now let's push it to the remote. Let's specify the upstream since we are creating branch for the first time. And now let's navigate to the GitHub website. Let's refresh the page. And we can see that we have 2 branches in place. However, we don't have any mentioning of creating a pull request. This is because we haven't made any new commits for our new branch. So let's go ahead and do just that. So let's create a new empty file. Let's stage that file. And finally, let's commit the file in question. And let's push our changes to remote. So now, as you can see, there is a mentioning of saying Git feature, which is the name of our branch, has recent pushes less than a minute ago. And now we have the option to create a pull request, this green button, which says compare and pull request. So let's investigate it. In the presented window, which says open a pull request, we can specify the title of pull request, leave comments. Additionally, we can assign reviewers, assignees, labels, projects, and milestones, and some of the linked issues. So to keep it simple, let's create a pull request and see what will happen. You can immediately create a pull request, or you can create a draft of pull request if you would like to spend a little bit of time drafting the actual pull request. So let's create a pull request immediately. And this is what a pull request would look like. As you can see, its status is open, and it is showing us that we would like to merge from the branch feature into the branch master. And we can specify some of the additional comments here, labels, projects, the same way as we were able to set it when initially creating the pull request. Finally, as you can see, we have some of the options available here. And if you remember from settings, we can disable some of these settings to allow only certain type of merge strategies. Finally, you have the option to close the pull request if you are not satisfied with the changes. So for simplicity's sake, let's choose a rebase option and hit rebase and merge. Then we would get a confirmation message asking us if we would like to confirm the rebase and merge. Let's go ahead and do that. And that's it. Since we have specified the name, the option to delete the automatically merged branches, we have the ability to restore the branch as it was deleted from the remote. Finally, all your currently open and existing PRs as well as closed ones can be found in this section called pull requests. And you have an option to view only open ones or the closed ones. And the last but not least, you have a mentioning of GitHub issues. So to create a new issue, you would simply type click the green button new issue, and here you can find some of the sorting fields to limit your currently displayed issues. If you're starting with a brand new repository, there won't be much information to be filtered, but let's suppose you're going to open a massive public repositories that have existed for several years. There would be, let's say, thousands of issues, and this sorting issue would allow you to narrow down the information which you are looking for. So let's go ahead and create a new issue. Hit the green button new issue, and from here you can find a screen which is somewhat similar to pull requests, where you have title, you can have comments, and additionally you can set some of the extra parameters such as assignees, labels, projects, milestones, linked pull requests, etc. So let's create our first issue, hit submit new issue. And in a nutshell, we have created a new issue. And just like with pull requests, we can create additional comments, change these additional parameters, and finally we can close the issues once we believe it was resolved. And if you look at the tab issues, you will find that it is no longer open, but now it is closed. And this, in a nutshell, covers how to use the GitHub web interface. Thank you very much for watching, and please check out more videos to your right to help you develop your IT career.